Section 6.6, Derivatives of Implicit Functions. We are going to do a couple more examples. They're pretty easy examples, they are. So this one has a c equals to f(ax) plus by plus cz, and c equals to fy is a solution to that, which solution means when if you plug this into that, the whole thing is identically equal, where ABC are constants, of course. We're trying to show here this particular equation exists, that is b partial c partial x equal to a partial c partial y. Now to do that, we will write this down slightly differently. So this is the same as f(ax) plus by plus cz minus c equal to 0. So that we have that equal to 0 relationship that we've been doing. Now and then we're going to plug c as fxy. So c is now depends on x and y in the function f relationship. And we're going to take partial derivatives. Now f has only one variable, as the big F does. So we will take the derivative. It will by the composite rule. Then we have f prime. So we will have f prime. We're taking derivative partial with respect to x. So then we will have multiplied by x has just a. Okay. We're taking partial with respect to x. So y is a constant, and then plus times a plus c partial z partial x, since we're doing x. And then minus, here's another partial z partial x, because right now we're taking z as a function of x, and this whole thing will be equal to 0. And then this next thing we'll do to y, the exact same thing. So we get f prime, which is the derivative of f, and then we're doing y now, so we end up with b. Okay, x is a constant in this case because we're taking partials with respect to y, and plus this is an x, and then c partial z partial y, because now we're doing y, and this is very similar, partial z partial y, and this thing is also equal to 0. Now to solve for partial c partial x and so on from here, we will have so what we have is f prime times, so a times f prime is equal to, we'll move this over and this over to the other side of the equation, so we will get 1 minus c times partial c partial x. We are just rearranging things a little bit here. Similarly, b times f prime equal to exactly the same deal, 1 minus c partial y partial z partial y. Okay, now and then the last thing we have to do is we just have to write out the last bit. So then we have so then f prime, let's solve the equation like this, f prime divided by 1 minus c. Okay, we'll move the c down here and move the a over here. So from this equation, we get f prime over 1 minus c is equal to 1 over a times partial c partial x. That's from the first equation. We're just doing some basic moving around. And then we'll do the same thing here, which is doing exactly the same thing, moving 1 over c down. We get this thing is also equal to, from over there, partial 1 over b partial c partial y. And this is exactly what we're trying to prove right here, because the two equations are the same thing. That concludes that problem. Next, we will do this particular function. Again, f is a big function with 2 variables, and you plug in some other function that has 3 variables, and all that is equal to 0 if when c equals psi xy is you can plug it in to make it come out identically 0. In other words, this is one way you can solve for c out of this particular mess. Now, what the mess really look like, we really don't care, and we'll just start working on it. Now, if c equals to psi xy, once you crank it out, we must show that this particular relationship takes place. And this looks like a fairly complicated relationship, but as it turns out, it doesn't take that long to crank this thing out. So we will take the partial derivatives and we are taking what are we doing here? Okay, we're doing imagine we'll plug this thing in here. Okay, remember this C get plugged in here, and then we're taking the partial with respect to y. Then we're doing everything with respect to y. So let's do it. So to take the partial derivative of this thing with respect to y, we get first f1. Okay, f1 times the small f with respect to y will be f2. Okay, and then there is c, it also has y in it, so we have to do c as well, plus f3 times partial c, partial y. All right, that's just the first side. And then the next thing we have to do is f2. That's the with relationship to the second position, but the answer is similar. Then g2, okay, just like here, there's f2 and g2. Because there's a y there, we have g2 plus g3, again, partial c, partial y. All right, and this whole thing will be equal to 0. Okay, because these things are identically 0. And what we'll get out of that? Well, out of that, we will, let's write partial c, partial y on this side and simply solve for it. What would happen if we solve for partial c, partial y out of this whole thing? Well, because everything is positive here, we will put a negative sign on top. I mean, for everything. And then we have the values that don't have it, we have f1 times f2, that one right there, f2 and g2, that's that one over here, and divided by, and the f1, f3, that's the first one in front of this one, the partial c, partial y, and the second one in front of it is f2, g3. And that's already a solution. See, I told you this stuff is easy. It just looks hard because there's so many symbols, but once you get past the symbols, you realize the stuff comes out pretty nicely.